We are finding relative extrema. We have the function f of x is equal to 3x squared plus 2x cubed, and I have that function graphed out, so I feel like looking at a picture is a whole lot more helpful before we get started. Now we're going to be wanting to find where this red dot's located on the graph, and this is going to be our relative max, and this will be our relative minimum. So remember, the first thing that we're going to be doing is finding the derivative, because we need to find those critical numbers. So I took the derivative, and we should get 6x plus 6x squared. We take the derivative, set it equal to 0, and then solve for x. Well, what I'm going to do here is I'm going to go ahead and factor this. I'm going to factor, or actually I'm going to pull a 6x out. Okay, so this is going to factor into 6x times, and in parentheses, 1 plus x. This is something you need to get kind of good at, and that is being able to factor stuff like this. Then we're going to take each factor, set it equal to 0. So we take the first factor, 0 is equal to 6x. We solve for x, well, x is 0. So 0 is one of our critical numbers. And then we're going to take the second one here and set it equal to 0. As you can see, we solve for x and we get x is -1. So our critical numbers are 0, -1. So the next thing we're going to do is draw us a graph, place our critical numbers on the graph, -1 and 0, and then pick some test points like -2, -0.5, and then 1. We take -2, we plug it into the derivative, and we get a positive number. So I'm going to indicate that with a line that has positive slope. And then we take -0.5, plug that into our derivative, we get a negative number, and that's going to indicate a negative slope. So we can see right here, because it's increasing and then decreasing, we can see that there's going to be a relative max occurring at -1. And then when we plug 1 into the derivative, we get a positive number out. So I just indicate that with a line that has positive slope. And so we know then 0 is going to be a relative min, because it's decreasing up to 0 and then increasing after 0. And of course, we've got to show all those steps mathematically. This was our derivative. We took -2, we plugged it into the derivative, and I got 12 out. Now, a faster way of doing this, instead of actually going through and doing all this arithmetic, you could take -2, plug it into the factored form here. So we know that this is going to be a negative number. And then we plug -2 in here. We know this is going to be a negative, and a negative times a negative is positive. Bam, we're done. But you can go ahead and work it out this way if you want. Same thing goes to here. Plug a negative in. You know this is going to be negative, but since this is -0.5 and that's less than 1, we know this will be a positive number. And a negative times a positive is a negative. And then we plugged 1 in, and we got 12 out. Now remember, these were our test points, and that's where there's going to tell us where the function's increasing and decreasing. Alright, well, I went ahead and plugged -1 into our function, and we get 1 out. Remember, -1 was one of our critical numbers, and this is our critical value. Plugging 0 into the original function, we get 0 out. So now we've got the 2 points for our max and our min. And I'm labeling that here as the maximum is occurring at -1, 1, minimum is occurring at 0, 0, and it's increasing from -infinity up to -1, and then from 0 to infinity, and it's decreasing from -1 to 0.